I didn't try to go really kind of detail into technical stuff because it's like 5 in the morning. I want to stay awake myself. So my name is Ali, and I'm data scientist by as a hobbyist, I can say. My PhD is signal processing, digital signal processing, telecommunication. I'm basically electrical engineering, and I got my PhD in Finland, and then I moved to US to pursue my postdoc in UCLA. I was there for a couple of years. Then I moved and worked in different industries. I started from chip design for cable modem, and then moved to finance, then finance, insurance, and my latest move, which is kind of I updated you here, is I kind of moved and started working with Meta, which is kind of Facebook, for their kind of a telecommunication effort and machine learning at the same time. Yeah, so this is my background. My talk here is more kind of related to the career path that you want to take. And you can see that I want to discuss with you that why I think that data scientists, in a sense that the job description as a data scientist will kind of go away, and some interesting development will happen to data science and machine learning. This can be controversial. It can be kind of people discuss it, but we will see what happens. But for that, I need to just tell you what is the kind of data scientist task. If you're going to a company, what are you supposed to do? And I'm doing it. I'm telling you in a kind of a sequence of things that you do. In general, what you want to do in 99% of the cases when you start kind of working as a data scientist, as previous speakers actually explained, you are tasked with predicting something, predicting a behavior, predicting market, predicting whether somebody will default on the loan, predicting where this robot should go, that kind of stuff. So for that, you need a model. And when you want to design a kind of a implement or train a model, what you need to do is that you need to first find data for it. And when I'm talking, as again, the previous speaker kind of, it was really nice gateway to my talk, is that we have a couple of models, couple of type of model that you can have. You can have unsupervised model. In those ones, you don't need data. Basically, like a clustering algorithms or kind of a neighbor detection kind of algorithm, or in a sense, I'm not sure kind of how to categorize reinforcement learning, because technically you don't have data, so you just but you have environment that interact with your model. But then you have, in most cases in industry nowadays, you have supervised models. It means that models that you show the example of correct or wrong, or classes, or whatever you want to name it, and then the model learn how to distinguish between these two classes, right, wrong, 1, 0, that kind of thing. For that, the first step is data wrangling. When I say data wrangling, it means that the data that you get, let's say you get a table from the apply for loan previously. And what you need to do is that you need to clean it. Why you need to clean it? Because kind of the data, real world data, is really dirty. It means that they're missing some values in some areas. Some people, because people actually generate human generate data, and humans are dirty. Humans are just like sloppy. So what you need to do first, you need to clean the data. Then you need to figure out what is happening in the data. You just do some statistical test on your model. And this is surprisingly that most people that they come to machine learning, they don't know that this part is like 80% of your job. it's not kind of a training the model, but this cleaning and exploration is like it's 80% of your time. You just like trying to figure out what's happening in the data and clean the data. The next step is, I call it feature engineering. Now, what is feature engineering? So imagine that you want to train a model that predict a behavior. Let's say you want to train a model that predict that somebody will default on a loan or not. Yeah, it's a really boring application of machine learning, but this is something that the most prevalent. If you go to financial kind of a company, this is one of the things that you have to do. When I say feature, it means that when a person comes in, they have some attributes. They have some, like in US, we have a credit score. They have some history of loan payment that they had. They had lots of kind of information, data points that you have about this person. Now, feature engineering tells you that which of these features or attributes are actually relevant to the loan default. And what I mean is, it means that if somebody has, like in one example, is that the credit score, which is going from 350 to 850, at what points you can, with some confidence, you can say that, okay, people below 600, for example, they are more probable to default on the loan. So these are the feature engineering, relevant features for predicting your target. Yep. So this is a kind of a, there are lots of tools on this one. It used to be extremely manual kind of process. Gradually, we are going, and then we have more and more tools to process the and data and find the features, but still it's a kind of a human aided kind of, or a kind of a tool aided kind of process. The next step is the training. The training is basically just, you have an algorithm, you choose based on it can be linear kind of a classifier, it can be nonlinear classifier, it can be a extremely nonlinear classifier like deep learning, but then I show your data to this model, and this model gradually learn the kind of that target, and it can give you the kind of and then after that you can just show your actual data, which is coming from future, and then you just show and predict for you that, okay, this person with some percentage, with some probability will default in future. Now, this is kind of a, nowadays it's completely automatic. It's really simple. It's just like a couple of lines you can write and then just train. In most cases, in like 90-something% of cases, it's just the. And the other thing is that with the advent of tools like AutoML, which is kind of, you can find it in Amazon AWS, or you can find it in Google GCP or Microsoft Azure. They have AutoML now, so it means that you can just leave it there, and it kind of finds you the best model in different categories of this model. It used to be, when I started like 6 years ago, it used to be the process, the performance was not that good, but nowadays data scientists need to kind of work a little bit harder to beat this AutoML, but still it's not there yet. I mean, it's not there exactly yet, to give you the best performance that you can get from really good feature engineering and kind of informed model training. Then we get to the fun part, because most of the people, they don't talk about this. Now, you imagine that you train a model on your computer on AWS, in Azure, wherever, but it should be used. When it should be used, it means that you should put it somewhere that people can interact with it. Just for example, if you have a kind of API, means that they call the API, they just get the result of it. And nowadays we just put it in a cloud. It used to be the on-prem kind of data centers. It means that some companies, they had their own set of servers and stuff, but now most of the companies, they are moving toward like a big players, like as I mentioned the names, like IBM, Microsoft, Amazon and Google, for example. Now, this one, when I joined, when I started machine learning, it was a really tedious process. It means that uh, some companies, they have like a dedicated teams, like they have this machine learning team engineers that they do for you. They have this ML kind of a DevOps person should be involved, and that kind of stuff. It's really messy kind of thing. However, it's kind of gradually moving towards something called MLOps. It means that machine learning operations, and that's the kind of thing that they try to handle the process. And what does it mean? It means that if you don't have to be even now, it's kind of a little bit like that you don't have to be a really full-blown developer to be able to deploy your model. Still not there. There are lots of kinks here and there. But it's getting better. It's getting better. And yeah, this is this deployment. Now, when you deploy the model, as I said, the model is trained on historical data. And what happens is that it learns what happens before and try to predict the future. And now imagine one example. I can tell you that the market, when the COVID hits, was completely anomaly. It means that something that never happened before. So personal experience, we had to retrain all of our models because it didn't work anymore. And just like a person who kind of was defaulting before, it was not kind of after the COVID, you had no idea with the model that you had. Everything was wrong. So you had to just figure out how to kind of train your models to take into account the new environment. Now, that's a kind of really harsh effect, really an anomaly. But in general, what happens is that because the situation changes based on in the future always, you have to monitor your model and you have to take care of the changes that happens, and then what we call as a drift, that your predictions start to drift from what you have. So you have to be able to do that. Again, this was a completely ad hoc boilerplate codes that you had to write even 2 years ago. Now there are some companies here and there, they're just popping up that you can just use their kind of a SDK, just put it in your model and then just monitor it. So again, becoming a little bit more automated now. Then the other thing is explainability. Now, there used to be models, linear models, like logistic, not exactly particularly linear, but anyway, logistic regression, linear regression, that you could explain that why your model predicted what it predicted. With the advent of neural network, especially the deep neural network, it's a kind of really interesting question, especially in practice, in like in your company when you're working. Again, a couple of years ago, nobody could explain why, when a deep neural network kind of says this is a cat or the dog, why is it saying that? Yep. But again, there are tools are coming in more and more to just explain that why. So if you had a deep neural network and then there was some prediction, you needed a person to just go in and dig in and figure out why is it kind of explaining this. Sometimes it's really almost impossible to do it. But then tools are coming in and it's getting kind of much easier to explain automatically in most cases. Now, these are the kind of, again, I just summarize it: data wrangling, feature engineering, training, deployment, monitoring, explainability. What is the likelihood of we end up with some services that make it much easier for us to do? For data wrangling, it's pretty high. It's kind of really human involved, but I'm pretty sure it will happen. That it make it so easy that the entry bar for data wrangling kind of will drop. Feature engineering, the same. Training, it's already there. Probably in like a couple of years, we will have it. Deployment, monitoring, and explainability, they are all coming. Now, what does it mean? It means that, are we doomed? It means that if you want to be a data scientist, is it a mistake to do it? I think you are. You shouldn't kind of a bank on that you will be a data scientist, but with some kind of a caveat here. This is my prediction. remind me in 10 years that this was it. In 10 years time, what I believe is that everybody, whether you are in engineering, if you are in business, if you're a physician, whatever you are expected to perform data scientist tasks. It means that we won't need a data scientist as a just data scientist. What we need is that we need a mechanical engineering, a kind of a person, a mechanical engineer who knows how to work with data. Or we need a business person who knows how to work with data. It means that train a model and work. So this will be something that imagine that in 1960s, you would say that I can work with the text editor. Yeah. But then nobody in 2001 or 2002 will ask you that, oh, do you know how to work with Word? It's given. You had to know it. Yeah. So that's what I mean by data scientists will be gone. And the thing that comes in is that the professionals that actually know how to work with data. This is kind of thing, this is my prediction. And if you want to choose your future path, take into account and observe and monitor that how these kind of data evolve. Now, as I said, I predicted something for future, and I tried to find a quote that says sometimes predicting future is kind of a futile. And I found the same quote from 4 people. I didn't have time to research it. So one of these persons, like one of the persons said that, and then the other one copied probably. But what it says that it's really hard to predict future. So take it with a grain of salt and monitor the whole data science and machine learning field. And it's a safe bet. Whatever field that you are studying, take into account that in a couple of years, maybe you are expected to be a data scientist anyway, whether you like it or not. Thank you very much.